Hi, I'm Lee Teschler from EE World and Design World, and I'm here with Monica Little from Keysight Technologies. She's going to talk to us a little bit about a power analyzer. Now, Monica, most power analyzers, they're used for analyzing the power quality on plants and utility lines, but that's not what this does at all. Can you tell us a little bit about it?
Well, it could do that too, but this is much more sophisticated piece of equipment, frankly. I think this equipment is the best for power design engineers who design any type of energy conversion devices, like DC to AC converters, any type of conversion of energy, or drives, VFD drives for motors, things like that. So what we did, frankly, we took one of our very popular scopes and we added all the power analysis functionality to it. So I think we should start back here to show how it is different from the back side, because what we have here, we have 4 power channels. Now, each power channel means that it measures voltage and current, each channel. So these voltages are isolated up to 1000 volts. And current, we can measure a couple different ways. We have internal shunts. Each channel has 2 shunts, 2 amp shunts and 50 amp shunts. And if you want to measure a higher current or you don't want to break the circuit, then you slide this door down and you can measure it through BNC connector via probes or CTs. So I'm running some simulated data here just to be able to show you what this does. This is the scope kind of view where you can assess and evaluate everything just like on scope. You can change your time base and scales, zoom in and out. Now the power analyzer part, it's under the blue button Analyze. And as you can see, I can analyze a different way. So I can have my group A. So maybe I need to look first what is the group A. To make it easier for 3-phase measurements, when I have complicated measurement on the back connections, we made this really nice, easy way to define what you are measuring. So with the touch screen, you can just pick whatever combination of channels you are using and what you are measuring. So I will set this. Once I have that done, I will go and look in Phasor diagram. Did I do my connections right? Is my system balanced? All that, again, really quickly, very nicely visual, big, large screens.
Could you also use that to see power factor?
That's a very good question. Well, the power factor I would probably find fastest right here in this power quality, where I can either have a power factor of that group, or I can look at power factor of each channel. So I see power factor of one channel is 0.98, I have a phase angle, I have a crest factor, all the information's RMS measurements, and these RMS measurements we made sure that we collected this innovative way where we make sure that we collect always integer number of and gapless measurement of data, so we don't lose any data. That way we can improve the accuracy of the measurements. The basic accuracy of this tester is 0.05%, but with this new technology, we deliver this RMS and the power quality measurements with very high accuracy, because we make sure that we don't lose any data. So those are your power quality measurements. Now, next thing is interesting. For example, you want to know what efficiency when you are designing, when your design is operating. So it's very quickly, again, you see this push of 2 buttons. There is your efficiency around 73% from one side to another side. And one more thing, there is other data what you can look, but mostly I want to show you now our harmonics. So you pick the signal. And what we do in the purple line is the calculating DFT, and here all your harmonics information in the table, and total harmonic distortion nicely, quickly there. And also we can look at it is in a bar chart, And what we also implemented is IEC standards, so you can see if your design is passing or failing the IEC standards.
Gotcha.
So there is a lot of information what you can get out of that. So we think that it's really valuable for design engineers for
sure.
power devices.
That's an interesting instrument, Monica. Thank you for taking us through it.
Thank you for paying attention to us. Thank you.